We should have 3 handouts this time. So you're going to begin with the 45, 45, 90 worksheet. And you're going to find the missing value for each of the 8 problems. There was one mistake on the worksheet. So the hypotenuse is the leg length times the square root of 2. Just 1 square root of 2, not 2. So that second square root of 2 needs to be marked out. Got the timer set for 15 minutes. Again, it's a video, so I'm not going to run the timer for 15. Keep track of the time. Try to get done in 10, 15 minutes. And when you're finished, you turn the video back on. You want to check your answers. There is an answer key for this worksheet posted in the back of the room. So let's go through the problems in the worksheet. Starting with problem number 1. You have to keep in mind that, again, we have an isosceles right triangle, which means 2 of the sides are equal. And so, since this length here is 8, that means the length of the here will also be 8. And we talked about before, in the last class, on the fact that the general triangle or toolkit triangle for 45, 45, 90 is 1, 1, root 2. So the scale factor between these two sides of the circle is 8, because 8 divided by 1 is 8. So to get to the x value, I'm going to take the 8, which is the scale factor, and I'm going to multiply by the square root of 2. So that means x is 8 root 2. Problem 2, again, the 16 is a leg length, so this length is equal to this length, this third slash hypotenuse. So this is an isosceles right triangle, so the problem 2, x value is 16. If I wanted to go to the hypotenuse, again using that 1, 1, root 2, the hypotenuse is root 2 times longer than 16, so 16 times root 2 is 16 root 2. Now, problem 3, we're given the hypotenuse, which is 12, and we're looking for one of the legs. So if I'm going from a leg to the hypotenuse, we're multiplying by root 2. It's kind of like this triangle up here. To get from the 1 to the hypotenuse, I think 1 times root 2 to get to the square root of 2. So this time we're going the other direction. So we're going from 12 back to one of the legs. So instead of multiplying by root 2, we're going to divide by root 2. So if you check your answer in that class, you would notice that after the x here, they have 12 divided by root 2. We're taking the length of the hypotenuse and divided by root 2. What you need to understand is this particular triangle, when you're going from a leg to a hypotenuse, you are multiplying by root 2 because it's getting bigger. And when you're going from hypotenuse back to the leg, you're dividing by root 2. So in problem 4, we have the hypotenuse, so these are the 2 equal sides. So from here to here, I would multiply by root 2, from the leg to the hypotenuse. So going back the other direction, I would be dividing by the square root of 2. So 24 divided by root 2 is the length of each x value. In problem 5, the root 2 and the x are actually the equal sides. So that means x is root 2. If I wanted to find the hypotenuse, since I'm going to the longer length, I would multiply by root 2. So the problem becomes 3 root 2 times root 2. So that's 3 root 4. So the square root of 2 times the square root of 2 is the square root of 4. The square root of 4 does simplify to 2. So the final answer, you're asked to find the hypotenuse would be 6. That's our problem 5. Hypotenuse would be 6. problem 6, again, we're going from a leg to the hypotenuse, so that means we're going to be multiplying by root 2. And this length and this length is the same, so this is 18. And 18 times root 2 makes the hypotenuse 18 times root 2. There's the last two problems. We are given a hypotenuse, these are two sides, so going from here to here is a multiplication of root 2. So going back the other direction, we're dividing by the square root 2. So x would be 22 divided by root 2, and this length would also be 22 divided by root 2. And then for the last problem, 8, the length of, actually it's a square, so all these lengths are 5. And going from the leg to the hypotenuse, so it means I'm multiplying by root 2. So x is equal to 5 root 2. If that doesn't make sense, you can go back and watch the video again. You'll have an opportunity to ask questions. What I want you to understand is that I'm going from a leg to a hypotenuse, I multiply by the square root 2. It's a little longer. If I go from the hypotenuse back to the leg, I divide by the square root. Just get this handout up, we'll come back to it, and do some simplifying on 3 problems. So when we have fractions with the square root in the denominator, we want to rewrite them so the denominator does not have a square root. So anytime you have a fraction with a square root denominator, we're going to rewrite it so there's no square root in the denominator. So the way to do that, going back to like the fraction work from middle school and elementary, we need to multiply both the numerator and denominator by the same value. So to get rid of the square root, we're going to multiply both the numerator and the denominator both by the square root of 5. And the reason why is because the numerator will become 3 root 5, and then the denominator will become the square root 25, because 5 times 5 is 25. So by multiplying the square root by itself, what we end up with is a perfect square under the radical symbol. So that means we can simplify that. So we end up with this 3 root 5 over 5. Now the fraction no longer has a radical in the denominator, and this is what we consider to be simplified. Now be careful with the fraction, and sometimes the two numbers, 3 and 5, sometimes they actually become a factor other than 1, and the fraction can be simplified even one step further. In this case, 3 and 5 only have a factor of 1, so this is the final answer. So the second problem going across the top. I want you to go ahead and think about what the step we just went through and see if you can simplify the second one, as well as the third one. Turn the video back on and you are ready to continue. Alright, so to get the denominator to have no square root in it, we're going to multiply the fraction by the square root of 3 over the square root of 3. So in the numerator, you're going to have 8 times the square root of 6. Since 2 times 3 is 6, they're within the square root, so that's the same exponent of 1/2. The denominator will be the square root of 9, since 3 times 3 is 9. If I take the square root of the 6, there's no perfect square factor in it, other than 1, so I can't simplify it. The denominator square root of 9 is 3. Since 8 and 3 do not have a common factor other than 1, this fraction is considered simple. On the third problem, it actually is already simplified. And from the start, I said we're trying to simplify fractions that have a square root in the denominator. The third fraction does not have a square root in the denominator, so we consider this fraction simplified. Go ahead and take a look at the next two. The bottom row. Turn the video back on and you are ready. Alright, so here we're going to multiply both the numerator and the denominator by the square root of 7. So the numerator becomes 4 root 7. The denominator becomes the square root of 49. So 7 times 7 is 49. The square root of 7 does not have a perfect square factor other than 1, so the numerator will remain 4 root 7. But the denominator will become 7. Since the square root of 49 is 7. Again, the fraction from here cannot be simplified further, since 4 and 7 do not have any factors other than 1. The next one, we'll multiply both by the square root of 6 over the square root of 6. What I end up with is 3 root 12 over the square root of 36. Now, the square root of 36 can actually be simplified to 6. The square root of 12 can also be simplified. So if you didn't simplify the square root of 12, you need to do that. Because again, you're going to find that this fraction can be simplified further once you simplify the square root of 12. So if you can do that, turn the video off, finish that off, and then try to simplify the fraction. Alright, so the perfect square factor of 12 is 4 times 3, so that means you end up with 2 root 3. The square root of 12 is replaced with 2 root 3. So what I end up with is the numerator is 6 root 3, since 2 times 3 is 6, over 6. And 6 divided by 6 is 1, so the final answer here is the square root of 3. As well as problems I mentioned, sometimes you can do a simplifying by getting rid of the radical and the denominator, and you can still do that work, and the fraction still isn't simplified. Here's a perfect example. Alright, so for the last one, go ahead and simplify this one. Let's see if the fraction can be simplified and simplify all the way. Put the video back on when you're ready. Alright, so this one here we're going to multiply by the square root of 5 over the square root of 5. So we end up with this 15 root 15 all over the square root of 25. So we have 15 root 15. Square root of 15 does not include a square factor other than 1 all over 5. So the square root of 25 is 5. 15 divided by 5 is 3. So the final answer is 3 root 15. I'm going to stop here with this first video, because there's a time limit of 15 minutes, and we're approaching 14 at this point. So go back to Canvas, or if you're not, you're already in Canvas, go back to Canvas and click on the next video link. This link will lead us to the end of the handout that we were working on 2 days ago, and then we'll move into the Geometry Day 3 handout after.